This is the lecture from Mrs. Roth General Science class. We'll be covering Module 9, Week 1. These are the supplies that you need to have with you while you watch this lecture. We're going to be discussing the lab report for Experiment 9.2, which will require that you have your colored pencils with you. You also need a blank piece of paper for taking notes. This week you're going to be cleaning out your binder, which will allow you to take out most of your papers from modules 1 through 8. This happens this Friday. It's on your assignment sheet. It tells you that you may take out all of your papers for modules 1 through 8 and take those out of your binder. You do need to leave in everything that's in the other section of your binder. Please do not throw anything away. I'd recommend that you just put a big rubber band around all of it and put them in the safe place. Especially your binder dividers, you're going to want to use those again next year for science. So today we're going to start talking about Module 9. The topic is, what is life? Scientists have come up with 4 criteria that define life. All life forms have to have all 4 of these in order to be considered a living organism. The first criterion that you need to write down is that all life forms contain deoxyribonucleic acid, which is called DNA. So please pause the video and write that criterion down. You should have this memorized as well. I want to help you learn how to say this big long word here, so I'm going to say it a few times and I encourage you to actually say it yourself. This word comes from deoxyribonucleic acid, and you can see there's the letters D, N, and A in there, and that's where we get the abbreviation. But let's try and say this a few times. It is deoxyribonucleic acid. Deoxyribonucleic acid. Deoxyribonucleic acid. You will sound very impressive if you can say this word at the dinner table. So what is deoxyribonucleic acid? Well, DNA is the set of instructions that takes the chemicals which make up life, chemicals like proteins and carbs and fats, and arranges them in just the right way so as to produce a living system. So DNA itself is not alive, but it takes non-living things and arranges them in just the right way to produce a living system. It's very much like this model airplane kit. The pieces that make up this kit do not make a model airplane. In order for the model airplane to be made, the pieces must be assembled according to the instructions. In the same way, the chemicals that make up a living organism require the instructions in DNA in order to form a living organism. What does DNA look like? Well, DNA is a molecule, and it is made up of atoms. Atoms are the smallest chemical unit of matter. Matter is something that occupies space. Examples of atoms are things like oxygen atoms and hydrogen atoms, chlorine atoms. Currently, there's about 316 different kinds of atoms. You may have seen this particular table before. This is called the periodic table of the elements, and this lists all the different atoms that man knows of. This particular one isn't completely up to date, as scientists are continually discovering and actually making new elements to put on this table. So, when we talk about what DNA looks like, we first understand what atoms are, and atoms link together to form larger building blocks that are called molecules. Molecules are two or more atoms linked together to make a substance that has unique properties. You're familiar with certain molecules. You know of the water molecule, for example. A water molecule is made up of two hydrogen atoms and one oxygen atom. Another atom you're familiar with would be the carbon dioxide molecule. That molecule is made up of one carbon atom and two oxygen atoms. And they go together, they bond together to make a carbon dioxide molecule. Now, these particular molecules that we looked at were fairly small, but DNA is quite different in that it is a really, really big molecule. Most molecules are made up of somewhere between 2 and 100 atoms that are linked together. For example, water molecules have 3 atoms, so do carbon dioxide. But DNA is made up of millions of atoms. So it is quite different and very big. A single human DNA molecule contains the equivalent information of 500 pages of information. So that DNA molecule is very big, contains millions of atoms, and contains a lot of information. One of your On Your Owns, On Your Own 9.2, asked the question, how is a cookbook like DNA? And this is a really good question, and I want to make sure that you understand this. A cookbook has recipes that tell you how to make many individual things and how to put them together in such a way as to make something. So it tells you how to take those individual ingredients to put them together to make something. In the same way, DNA has information that takes many individual chemicals that are not alive and puts them together in such a way as to make something that is alive. So the DNA itself is not alive. It's taking chemicals that are not alive, and it gives the instructions for how to put them together. Just like a recipe takes the flour and the sugar and the eggs, puts them together, or the recipe tells you how to put them together to make a cake, for example. Now, it is the structure or the way that the DNA is put together, that is how it stores the information that it gives for producing life. It does that initially through the shape of the DNA molecule. The DNA molecule is made up of a double helix, kind of a spiral, 2 spirals spiraling around themselves. This particular discovery was very important, and it was made in 1953. Dr. Watson and Dr. Crick discovered the DNA structure or shape of the molecule. And this was so important that they actually won the 1962 Nobel Prize in Physiology and Medicine for making this discovery. So you can see that scientists, this wasn't something discovered hundreds of years ago. This is relatively recent and very important to our understanding of DNA. So when we look at this double helix structure, there's a couple different parts of it that we want to point out. First is the DNA backbone. These are the long strands of atoms that are linked together in just the right way. DNA molecules also contain units that are called nucleotide bases. There are 4 different nucleotide bases: cytosine, guanine, thymine, and adenine. Now, in our actual DNA, or the DNA of anything, they are not colored like this, but we're using these colors to show the 4 different nucleotide bases. Notice that they're very random. They can show up in any different type of pattern, and it's that different organization of the 4 different nucleotide bases that gives that information. So we have these 4 different nucleotide bases, and it is just how these bases are combined that stores the information for creating life. Cytosine and guanine are 2 nucleotide bases that can connect with each other, as well as adenine and thymine connect with each other. Now, it's important to realize that these are the only pairs that go together. So you'll never see guanine connected with thymine or adenine connected with guanine or anything like that. So you need to come up with a method of remembering which ones go together. The way I remember it is if you put them in alphabetical order like this, the first and the last go together and the middle 2 go together. So here are our 4 nucleotide bases. Thymine and adenine go together, guanine and cytosine. So if we were given a portion of a DNA molecule, in this case, if it was red, we would assume we would connect that here with red as thymine in this example. Again, there's no colors in our actual DNA. We're just using these colors to help us to represent these nucleotide bases. So if we had a thymine base, it would have to connect with an adenine base. If next on our DNA strand we had cytosine, we would know that after that, or connected to that, would have to be guanine. If we had adenine next, that would be paired up with what? I want you to pause the video and write that down. What would the adenine, what would that have to be connected with? The correct answer is thymine. Only adenine and thymine go together. If we had a guanine, what would that connect with? Cytosine. Again, now if we had a thymine, think to yourself, what would that connect with? That would connect with adenine. Finally, what if we had this one? If we represented it like this, what would that connect with? That would be cytosine, so that would connect with guanine. So the 4 nucleotide bases in DNA are arranged kind of like Morse code to contain all the information necessary for life. We're going to pause here because I can only record a certain amount of video, so we'll pause right here and resume in part 2.